The eyes of the Navy in the sky, using their advanced radar and communication system to identify enemy targets and alert friendly forces of nearby threats. These special aircraft can utilize powerful tactics, such as jamming adversary electronic equipment and deception to reduce the effectiveness of enemy radar and communication systems. Aircraft have been a vital factor in the United States Navy to carry out a wide array of tasks for decades. The United States Navy relies on their fleet of aircraft for aerial warfare. These aircraft engage in airborne combat and provide close air support. They also come equipped with special landing equipment that allows them to take off from aircraft carriers. Most importantly, these aircraft patrol the friendly waters of the Navy and are designed to carry out numerous long-term ocean operations. These operations include reconnaissance, combat, warning command and control, electronic warfare, and logistical operations. One of the most recognizable and strong aircraft of the United States Navy is the F-35C Lightning II. The aircraft is part of the Joint Strike Fighter program. The F-35C is uniquely designed for operations involving aircraft carriers. The F-35C has great maneuverability, robust landing gear necessary for landing on carriers, and a big internal fuel storage, making it ideal for long-range missions. The jet comes equipped with automatic cannons, air-to-air missiles, short-range missiles, medium-range air-to-air missiles, cruise missiles, and guided drop bombs. The aircraft can travel at speeds up to 1,042 knots and has a range of approximately 1,200 nautical miles. Fighter jets have undergone significant evolution over time, progressing through distinct generations marked by technological advancements. The earliest jet fighters emerged during and after World War II, characterized by straight wings and basic construction materials like wood or light alloys, forming the first-generation jet fighters. These aircraft lacked advanced avionics and were primarily focused on air-to-air combat. Subsequent generations saw substantial technological leaps. The fourth generation introduced maneuverability, fly-by-wire systems, composite materials, synthetic radar, and infrared capabilities, enhancing aerodynamics and stealth. In the early 1960s, the Navy began to search for a superior heavy jet transport that would be better than the Douglas C-133 Cargomaster and complement the Lockheed C-141 Starlifters. The Douglas C-133 Cargomaster was an American large turboprop cargo aircraft. It was designed to meet the requirements of the United States Air Force Logistic Carrier Support System for a new strategic transport. It has a high-mounted wing, external blister flaring on both sides for the landing gear, and rear and side-loading doors that ensure easy access to the large cargo compartment of the aircraft. The C-133 carried many large loads, including Atlas and Titan ICBMs. The C-133 Cargomaster was operated by a crew of 5, including 2 pilots, a navigator, a flight engineer, and a loadmaster. The aircraft measures approximately 155 feet in length, has a wingspan of 179 feet, and a height of 48 feet. It's powered by 4 Pratt & Whitney T-34P9W turboprop engines, each engine being able to produce a force of up to 7,500 horsepower. Along with the incredible power, the aircraft has an empty weight of 54,550 kilograms, a gross weight of 124,738 kilograms, and a maximum takeoff weight of 129,727 kilograms. In terms of performance, the C-133 is capable of flying at a maximum speed of 312 knots, or 578 kilometers per hour at 8,700 feet, has a cruise speed of 281 knots, or 520 kilometers per hour, and a range of 3,560 nautical miles with a payload of 24,000 kilograms. On the other hand, the Lockheed C-141 Starlifter is a long-range strategic airlifting aircraft that is specially designed to transport large quantities of passengers or cargo from one place to another. The underside of the plane accommodates a retractable tricycle landing gear equipment that consists of a twin-wheel nose unit and 4-wheel main units. The C-141 Starlifter gets its power from 4 TF-33 turbofan engines, each of which is capable of generating a force of up to 21,000 pounds. Typically, the aircraft is operated by 4 crew members. The aircraft also utilizes high-mounted wing configurations that enable internal clearance in the cargo compartment of 10 feet wide, 70 feet long, and 9 feet high. Due to this large amount of storage capacity, the C-141 was capable of carrying large weapons like a complete LGM-30 Minuteman Intercontinental Ballistic Missile, or ICBM, in its container. The aircraft can carry a maximum load of 32,136 kilograms over short distances. In the case of personnel, the aircraft can carry a maximum of 154 fully equipped troops, alongside 123 paratroopers and 80 to 85 litter patients at once. In terms of logistical capabilities, one important aspect of the C-141 was the floor height of the cabin, which was 50 inches above the ground. This allowed for easy access to the cabin with the help of the large rear doors that were incorporated into the upward sweeping rear fuselage. This section is a large single-piece hydraulic loading ramp that is used for simplified loading and unloading procedures of both vehicles or cargo in general. The U.S. Army's need for a larger cargo boat to transport their massive equipment resulted in the development of the CXX design in 1963, with the first design being the earlier 6-engined CX-4 concept. This new design compromised 4 engines and remarkable specs. It came with a gross weight of 550,000 pounds, a payload capacity of 180,000 pounds, and a cruising speed of Mach 0.75. Utilizing high-bypass turbofan engines, a cutting-edge technology at the time, was crucial for achieving the required thrust and fuel efficiency. This project, later known as the C-5, not only transformed military aviation, but as General Dwan H. Cassidy stated indirectly, propelled advances in commercial aviation, especially with the development of the TF-39C5A engine. The selection process was fiercely competitive. However, it made Lockheed emerge victorious with its cost-effective design in 1965, making way for an aviation milestone. The C-5 Galaxy's journey progressed from just a concept to a formidable force in the skies. The focus was shifted to refining the C-5's capabilities through advanced technology and engineering. The story of the C-5's versatility is not just about size or power, but also shows the relentless pursuit of avionic aviation and functionality. Each successive model, from the original C-5A to the ambitious C-5M Super Galaxy, represents a jump forward in military aviation technology, particularly in the avionics upgrades. The C-5A is the ancestor of this line, and it set the stage with its impressive dimensions and capabilities, serving as a platform for rapid enhancements. Regardless of having initial setbacks like wing structure issues, solutions and upgrades were implemented non-stop, showcasing the commitment of the United States Air Force to maintaining the C-5 status as a premier airlift asset. Continuing with the C-5B, the aircraft came with a set of refined avionics, stronger wings, and more efficient engines, showcasing a significant upgrade from its prior version. However, the progress and upgrades of the aircraft didn't just end there. A specialized variants of the C-5, like the C-5C, were introduced. The C-5C was specially designed and crafted for unique missions requiring large cargo spaces, further diversifying and enhancing the C-5's utility. As technology advanced, so did the C-3 with the introduction of the Avionics Modernization Program AMP and the subsequent C-5M Super Galaxy, a symbol of military transport innovation with state-of-the-art avionics, significantly enhanced performance, and a renewed life for this beast in the skies. And this journey from the C-5A to the C-5M, the Galaxy's evolution showcases how avionic advancements have not just improved an aircraft, but transformed it into a symbol of American air power and technological reach. The continuous advancement of the C-5 Galaxy variants, with each of them being made more sophisticated than the last, illustrates a corresponding evolution in training protocols to ensure that both the crew and the aircraft are ready for any emergency scenario. This aspect of readiness is not just about mastering flight mechanics, but also encompasses a comprehensive preparedness for diverse operational situations. A prime example of this multifaceted training approach is the exercises conducted by aeromedical evacuation squadrons. In these high-fidelity situations aboard the C-5M Super Galaxy, AES personnel engage in intricate medical scenarios, replicating the intense and unpredictable conditions of real-world medical emergencies. These training missions are crucial as they keep the medical team's skills sharp and responsive, ensuring that they're always ready to provide any form of critical care in the air. This aspect of training is indispensable as it fills the gap between theoretical knowledge and practical application, ensuring the AES team's proficiency and preparedness for any upcoming scenario. This commitment to dedicatedly go through extensive training sessions highlights the multifunctional role of the C-5 Galaxy, not just as a transport vehicle, but also as a vital component in a wide array of different military operations, including critical medical interventions. The rigorous training exercises, such as those conducted by the Aeromedical Evacuation Squadron, are just one of the many comprehensive preparation tasks and safety measures that keep the C-5 Galaxy mission pre-flight checks ready. Equally critical to this readiness is the process of pre-flight checks, an important part of the crew's routine that ensures the aircraft's optimal performance and safety at every mission. Before the aircraft takes off for any flight, a thorough examination of the C-5's vital components is conducted, with particular attention to its powerhouse engines, robust landing gear hydraulics, and sophisticated flight avionics systems. These pre-flight inspections are not just checks, but essential procedures maintaining and guaranteeing the aircraft's integrity and functionality. The engine checks include addressing not only the mechanical aspects, but also software functionality and performance metrics. The inspection also often extends to the landing gear hydraulics, ensuring smooth operations in both takeoffs and landings, and the avionics systems, which are the nerve center of the aircraft, controlling navigation, communication, and other critical flight systems. This process of pre-flight checks guarantees the safety of the crew and the aircraft, and is a testament to the unwavering commitment to safety and reliability in maintaining the C-5 Galaxy status as a battle behemoth of the U.S. Air Force's strategic airlift capability. Apart from the comprehensive maintenance training exercises that prepare crews for a variety of scenarios, another crucial aspect in ensuring the C-5 Galaxy's operational readiness is its meticulous maintenance process. This extensive and detailed procedure is vital for keeping the aircraft in peak condition. Maintenance on a C-5 is not just a routine check, it's a thorough and complex operation essential for the aircraft's longevity and performance. The key focus of this maintenance regime is examining and testing the control surfaces, including the rudders and ailerons. These components are crucial for the aircraft's maneuverability and stability in flight, and ensuring their proper functioning is not just about mechanical efficiency, but also about ensuring the safety of every mission. This process involves intricate checks and balances, testing each component's responsiveness and integrity. Maintaining the C-5 can be very challenging as it's very large and heavy in size. Its landing gear especially poses significant challenges. Weighing a staggering 380,000 pounds when empty, the aircraft requires specially designed equipment to lift it off the ground for maintenance. This is where 6 powerful fuselage jacks come into play. Each of these jacks is capable of lifting more than 60 tons. These jacks are carefully placed at key points along the aircraft, the front, the middle, and rear, to distribute their weight evenly and ensure a stable and secure lifting operation. The importance of these jacks in enabling efficient maintenance cannot be overstated. They provide technicians with the access needed to service various components and systems precisely and expertly. The C-5 Galaxy has been used by the United States Air Force in many operations since 1969. The airlift had provided its support to the United States military in conflicts including Vietnam, Iraq, and Afghanistan, along with Allied support, such as Israel during the Yom Kippur War and operations in the Gulf War. The Lockheed C-5 Galaxy has also been active in distributing humanitarian aid and disaster relief, and supporting the U.S. space program as well. Although lifting the C-5 with these jacks is a lengthy process, it's critical to the aircraft's thorough and ongoing maintenance regime. After these extensive maintenance activities, a final but crucial step is to test and verify the functionality of all systems. This ensures that every part of the aircraft, from its engines to its smallest sensor, is fully operational and meets the stringent standards required for the C-5 to return to action. This detailed process reflects the high standards of care and precision, fundamental to the operational success and longevity of one of the Air Force's most significant assets. Another pivotal element in the C-5 Galaxy's operational framework is the specialized training exercises for flight engineers and loadmasters. These professionals play crucial roles in the aircraft's operation, where flight engineers are responsible for monitoring and managing the aircraft's complex systems, and loadmasters oversee the loading, balancing, and safety of the cargo. Their training is tailored to equip them with the skills and knowledge necessary for these highly specialized tasks, blending theoretical learning with practical hands-on experience. This training ensures the flight engineers can adeptly handle the technical challenges presented during flights. At the same time, loadmasters are proficient in optimizing cargo space and maintaining the aircraft's center of gravity. The C-5 Galaxy's remarkable capabilities and role as a linchpin in the U.S. Air Force's airlift capacity results from an intricate tapestry of elements, ranging from the rigors of maintenance, ensuring every gear and gauge is in top condition, to the specialized training of flight engineers and loadmasters. Each aspect plays a pivotal role. And this brings us to the end of the video. If you enjoyed, then please show us your support by hitting the like button and subscribing to our channel. And don't forget to turn on the bell icon so you never miss another video from us. Thanks for watching. We'll see you in the next episode.